Hi Shertayaa, this is Mr. Smith, and I'm going to go over these two problems that you asked about. In this first problem, it says determine the present value that must be invested to have a future value A at simple interest rate R after time t. So if you look at our formula sheet, there's two formulas for simple interest. This first one just gives you the interest if you know what P, R, and T are. Now when we talk about future value, that's A, that's the value of your money after T years, and P is the current value of your money, basically what you're putting into the account. So this is the formula that we're using, and I'll use this form. You could do it in either of these. So we have A is equal to P times 1 plus RT. And in this problem, A is 3,000. We have to find P. Remember, that's what we're looking for. And then the interest rate is 1.55%. You'll have to move the decimal 2 places left. So it'll be 0.0155 times T. Now 9 months, your time should be in years. So you could write this as 9 out of 12 months. That's the number of years. It's basically 9/12 of a year. And so now let's get our calculator. This is where things might be a little more difficult for you since you don't have this one yet. So we need to evaluate this. Now you could use any calculator. You're going to multiply. You could do 9 divide 12, multiply that by 0.0155, and then add 1, and you'd get the same thing. I'm just going to go ahead and put it all in 1. So 1 plus 0.0155 times, and then this is our fraction button here, and we'll put the 9 and then the 12. And so we will get 3,000 is equal to P times this number. I'm actually going to put it before the P. If two numbers are multiplied, the order doesn't matter. So we have 1.011625 times P. Now, so basically what we have is an equation to solve for P. To get P by itself, this is 1.011625 times P. If we divide, we can get rid of that on this side. These cancel. We have to divide the other side by the same number. So if we take 3,000 and we divide by 1.011625. By the way, you don't really want to round here since it's not too much trouble to put all these digits in. So we get P is 3,000 divided by this number here, right? Because on this side we're just left with P equals this number here. So 2965. Now here you have to notice it says round up to the nearest cent. So this is a little different, although in this case if we round to the nearest cent, because of this 5 we're going to round up. But even if this were a 1, when it says round up, that means this number will move up to the next digit. And so this is going to be 0.53. And so that's how you get the answer to that problem there. Let's go ahead and move on to the next. So here it says principal represents an amount of money deposited in a savings account subject to compound interest at the given rate. Find how much money there will be in the account after the given number of years. Now normally for years, or when it's daily, we use 360, but it's telling you here to use 365. And so we need to use the formula for compounded interest that's compounded daily or n times per year. That's this formula here. Notice on our list, it's the future value or the amount in the account for compound interest paid n times per year. In this case, the interest is compounded daily, so it'd be 365. That's what they told us to use, but this is our formula here. So we have A equals P times 1 plus R over N to the NT power. Oops, and you can't see that. Let me switch back. I'm on the wrong one. Oh no, this is right. Okay. And I've already put the answer in here. Let's see. I need to switch back here. I was right the first time. Okay, so here we go. So in our problem, P is our principal, 30,000, times 1 plus R. So again, we'll move the decimal 2 to the left. It'll be 0.045. Now that's over N, which in this case is 365. And then to the NT power, so 365 times T, it was 17 years. So this is basically the formula that you use for compound interest that's compounded n times per year. And basically you're putting a lump sum into the bank of $30,000. And this is how you figure out the interest that you're going to have after 17 years when it's compounded daily. All right, so it's time to get the calculator out. Now again, I would just point out the reason why students struggle with this if they have to do it on a more basic calculator is because of order of operations. So if you do this without a nice calculator, and I know you're waiting on your calculator, first you'd want to find what this is in parentheses. So divide these and add 1, because you always do divisions before addition. And then whatever you get, you're going to take that to this power. Now you'd want to do 365 times 17 and take this, what you get in the parentheses, to this power. And then the last thing you would do is multiply by 30,000. Now you don't have to really worry about that if you have this calculator. So we'll just do 30,000. And we'll do 1, so parentheses, 1 plus. Now you could hit the fraction button first. I actually like to put in the numerator first, so 0.045, and then hit the fraction button. So you can hit it before or after, but either way you can see the fraction as we build it. And then we want to hit the exponent button, which of course is this button here. So 365 times 17. And when we hit enter, by the way, I always like to kind of keep an eye as I'm typing in that I'm putting the numbers in correctly. You know what they say, garbage in, garbage out. Make sure what you're typing in is correct. And then, by the way, if you wanted to see everything you typed in, you could arrow back to see all that was put in. Let's go ahead and hit enter. And so we get our answer. It's 64,466. Now this does say round to the nearest cent. I'll just right here. So you always want to watch where you're putting your answer. It'll tell you what it's looking for. In the last problem it said round up to the nearest cent, so that always rounded up to the next penny, whereas here this is rounding to the nearest cent. Well, because this is a 1, this will be 79 cents. And so that's the answer that you should get. Whoops, let me pull this up a little bit. All right, I hope that helps. If you have any more questions, let me know.